Okay, in this video we shall discuss next conic section, ellipse. So ellipse is a shape when the plane intersects with double napped right circular cone. So that is, if this is alpha angle between generator and axis of cone, then suppose if this is the plane, then we consider this angle as beta. Okay, beta is angle between plane, plane and axis of cone. Okay, now the case is if alpha is greater than alpha is less than beta, that is beta is greater than alpha, this angle of intersection of plane and axis must be greater than alpha and less than 90 degree. If it is 90 degree, right, then we get circle, right? So this is the condition when we get ellipse. Okay, so beta is greater than alpha and less than 90 degree, and this shape is called ellipse. This is the shape which is called ellipse. Like we defined parabola as a set of all points, we can also define ellipse as set of all points or locus of a point. Okay, now you can see that ellipse is made up of many points. Okay, and these points satisfy a condition, that is, if you consider any point on the ellipse, then sum of the distances of that point from two fixed points which are inside the ellipse is always constant. That is, suppose if you consider a point here, for example P, and let me consider this as F1 and F2, okay, two fixed points, then this sum of these two distances, that is Pf1 plus Pf2, is always a constant. So for example, if you consider some other point here P1, then P1 F1 plus P1 F2 is also equal to this, right? So that is why we say that ellipse is locus of a point or set of all points. Sum of the distances of that point from two fixed point is always a constant. Suppose if you consider somewhere here a point P2, then there is P2 F1 plus P2 F2 is also equal to the same number. So all these distances are same. Okay, so definitely if you consider any points, so this is how we can define ellipse as a set of all points or locus of a point. Okay, in the ellipse these two fixed points are called focuses, that is we call them as foci. Okay, one focus, second focus, plural form of focus, that is foci. Okay, F1 and F2, and line joining these two points, passing through these two points, is called major axis. Okay, with these two as end points. So if I consider A and B, the line AB is called major axis. And midpoint of F1 and F2, so midpoint comes somewhere here, that is called center of ellipse. Okay, this point is called center of ellipse. Okay, center. And a line through the center perpendicular to major axis is called minor axis. This line, okay, which passes through center and perpendicular to major axis, whose end points lie on ellipse. So see, if I consider it as CD, then CD is minor axis. Okay, so this is major axis, minor axis, and end points of major axis are called vertices. So this is minor axis. So these are the different parts of ellipse. Okay, focus, foci, and vertices, and major axis, and this is center and minor axis. So this is all about basic concepts of ellipse. Now if A and B are end points of a line, then it has a particular length, right? So for different ellipse, different measurements. Okay, we denote it by 2a. So that is 2a is considered as length of major axis. Length of major axis is considered as 2a, and definitely half of the major axis is considered as semi-major axis. Definitely it is equal to a. Okay, it is center of A and B. Similarly 2b, we consider b for minor axis length. Okay, 2b is length of minor axis, and half of minor axis is considered as b, that is semi minor axis, that is considered as b, and distance between foci is considered as 2c. distance between foci, okay, so that is 2c, and definitely it is center of focus as well as vertices. So semi distance between focus and center, or distance between center and one of the foci, is c. Okay, c is this distance you can consider. Okay, half of the distance between two foci. So these are the different notations we use: a, b, c. A is length of semi major axis, b is length of semi minor, half of minor axis, c is distance of center from one of the foci. Okay, now we shall discuss about that constant value. So that is, in the beginning I told that if you consider any point on the ellipse, then sum of the distances from two fixed point is always a constant. Okay, so now let me consider major axis, okay, which is on the focus a and b. Now this point is also on the ellipse, so therefore af1 plus af2, that is sum of the distances of point from two fixed points, right? So if you consider any point, then you have to consider like that only, that will be the constant value, right? So now if I consider af1 plus af2, right, that value is constant value. Okay, let me check here. af1, so this is center. Okay, af1 is equal to, this distance is nothing but half of the major axis minus this distance. Okay, so af1 is nothing but a minus c. So af1 is equal to complete distance from here to here, that is length of semi major axis a, minus this portion will give us af1, right? So this portion is nothing but c, distance between center and one of the foci. So therefore af1, instead of af1 I can write a minus c, right? Then plus af2. af2 is nothing but this distance from here to here plus here to here. From here to here it is nothing but length of semi major axis, that is a, plus this distance is nothing but c, right? So this is how we can find minus c plus c, that is equal to a plus a to a. So therefore if you consider any point, the sum of the distance is always equal to 2 times a. Okay, so just remember this value 2a, where a is nothing but length of semi major axis. It is different for different ellipse. Okay, now let me discuss the relationship between a, b, c. What is a? Length of semi major axis, length of semi minor axis, and distance between center and one of the foci. Okay, now suppose if I consider a point here p. Okay, it is a point on ellipse, and we know that pf1 plus pf2 is a constant value. Just now we discussed that this constant is always equal to 2 times a, right? That is pf1 plus pf2. If you consider any point on the ellipse, the value is always equal to 2a. And now pf1, so we know this value, distance between center and focus, it is c, and distance between center and this value, that is nothing but length of semi minor axis, it is b. So since it is perpendicular, it is nothing but square root of b square plus c square using Pythagoras theorem. Similarly here it is c and b, so using Pythagoras theorem, square root of b square plus c square, correct? So pf1 is nothing but square root of b square plus c square plus square root of, again same thing, b square plus c square is equal to 2a. This same, so 2 times b square plus c square is equal to 2a. You can cancel 2, so therefore a is equal to square root of b square plus c square, right? So this is the relationship between a, b, c. You can also simplify it to a square is equal to b square plus c square. So we can also simplify to c square is equal to a square minus b square. C is equal to square root of a square minus b square. So like this, in different way you can transform it. Okay, so this is the relationship between a, b, c for ellipse. So it is different for hyperbola, so you should know this. Okay. Okay, next we shall discuss special cases of ellipse. Okay. Now first one is if c is equal to 0. So that is distance between foci is 0. So two foci coincide each other. So in that case, what happens here? Square root of a square minus b square becomes 0. That is c is equal to 0. So a square minus b square is equal to 0. A square is equal to b square. So definitely a is equal to b. So because these are lengths, so we will not consider plus or minus. A is equal to b. So in that case, ellipse reduces to a circle. Okay, length of semi major axis will be equal to length of semi minor axis. So therefore these two distances will be equal. So in this case, the ellipse becomes circle. Okay, the second case is when a is equal to c. So when a is equal to c, what happens here? C square minus b square is equal to c. So therefore square root of c square minus b square is equal to c square. So c square minus c square is equal to b square, that is b square is equal to 0, which implies b is equal to 0. So that means you don't find minor axis. So in that case you will find only a straight line. Okay, no minor axis. If there is only minor axis, then you will find like this shape. Okay, otherwise it will be a straight line, right? So for if a is equal to c, so we will get a straight line. Okay, these are the two special cases of. Now we shall discuss eccentricity of an ellipse. Okay, so eccentricity means it tells us how different the shape is. Okay, it differentiates between ellipse, hyperbola and circle. It is a number which tells us about the shape. Okay, so that is all about eccentricity of ellipse. Now eccentricity of ellipse is denoted by E, and it is nothing but a value which is the ratio of distance of the center from one of the foci C to the distance of center from uh, one of the vertices, that is A. That is this distance divided by this distance. Okay, this ratio is called eccentricity of an ellipse. You know that C is less than A, right? So A is greater than C here. So therefore this value is always less than 1. So therefore E is always less than 1 for ellipse, for an ellipse. So that is all about eccentricity of an ellipse. A is equal to C by A. Okay, now we shall discuss standard equation of ellipse. So equation of ellipse means it is a condition for all these points. Okay. Now we will consider center of ellipse on origin and major axis along x-axis and minor axis along y-axis. Okay. So if I consider two foci f1 and f2, and these are the two vertices. Okay, now let me consider. Okay, we know that distance between center and one of the foci is always equal to c, right? Total distance is 2c, so therefore this distance is equal to c. So therefore I can write coordinate of this focus, that is coordinate is, I think it is on x-axis, so distance is c and y coordinate is 0. Similarly here minus c comma 0 in the negative x-axis, so therefore coordinates of two foci are c comma 0 and minus c comma 0. Now here if I consider total length is 2a, length of major axis, so therefore half of the length is a, so therefore coordinates of vertices definitely a comma 0 and minus a comma 0. So these are the coordinates of vertices. So here also you can find coordinates. Okay, there is no any name for it, and endpoints of minor axis you can say. So coordinates are this, length is b, right? Since it is on y-axis, 0 comma b and here 0 comma minus b, endpoints of minor axis you can call it as. Okay, so these are the basic definitions or coordinates of ellipse. Now suppose if I consider any point, that is p x comma y on the ellipse, then pf1 plus pf2 is always constant, that is pf1 plus pf2 is always equal to constant, that value is nothing but 2a. Now using distance formula, and if you simplify, at the end we are going to get x square by a square plus y square by b square is equal to 1. So this is the equation of ellipse you have to remember. Okay, then you can go through the derivation which is in the book. Okay, but you have to remember this formula, that is x square by a square plus y square by b square is equal to 1. Equation of ellipse. So for which are the conditions? For major axis on x axis, minor axis along y axis, and center on ellipse. Okay, definitely foci always lies on major axis, so therefore if major axis is along x axis, then foci lie on x axis. Okay, so these are the cases. So this is one case, that is considering major axis along x axis and center on origin. So there is one more case. Okay, this is the second case, so in which the major axis lies along y axis. Okay, you have only two cases for your syllabus, center always on origin. Okay, in both cases, but in this case major axis along y axis, so definitely foci lie on y axis, that is major axis. So in this case coordinates of foci 0 comma c and 0 comma minus c, because they lie on y axis, x coordinate 0. Similarly coordinates of vertices, that is 0 comma minus a and 0 comma a, so because they lie on y axis. And definitely end points of minor axis, I think b comma 0 minus b comma 0 and b comma 0. Okay, these are the coordinates for foci, vertices, and end of minor axis. Okay, major axis along y axis, minor axis along x axis. For this shape, equation is x square by b square plus y square by a square is equal to 1. So in the previous case it was x square by a square. Okay, but for this case it is x square by b square. So therefore these are the two cases you have to remember. So in this case major axis along x axis and minor axis along x axis. The next we shall discuss latus rectum. So here latus rectum is nothing but a line segment through the focus, okay, perpendicular to major axis and whose end points lie on ellipse. So this line segment AB is called latus rectum. In the same way this line is also called latus rectum. Okay, so like we discussed in parabola. So this is the line which passes through focus and perpendicular to major axis, end points lie on ellipse. So this is called latus rectum. Then there is a formula to find the length of latus rectum. Length of latus rectum, that is equal to 2b square by a. So using the equation you can derive this formula. Okay, but you just remember that is 2b square by a. This is the length of latus rectum, only AB. Okay, not both AB and CD. Length of AB is 2b square by a. So if you consider both the latus rectum, then it becomes 4 times b square by a. That's all. Okay, but whenever they ask you to find length of latus rectum, that means they ask you to find only length of one line. Okay, that is 2b square by a, and definitely they will give you the value of b and a. Right? So this is how you find length of latus rectum for an ellipse. Okay, these are the different concepts of ellipse. In the next video I will discuss problems on this concept.